Hey guys, this is the 8.2 homework. I'm going to run through it. So for the first three questions, we're going to draw an angle, the given measure and standard position. Sorry for the typo. So we have 110 degrees. Now, angles require two sides. The first side, the initial side, sits stationary on the positive x-axis, while the other side is going to be rotating either counterclockwise or clockwise. In this case, if it's positive, it runs counterclockwise. So 110 degrees. If you're familiar with your corners, that this right here would be 90 degrees, this would be 180. So if this is 90 degrees, I need to rotate 20 more degrees, so maybe just put it about right there. And I'm not going to forget that I'm going to show the rotation by drawing another arrow that kind of just draws the path or how much it rotated. So this right here is 110 degrees. For 450, so we're going to have this as our stationary initial side. We have to at least go 360, so 450 minus 360 is 90 degrees. So that means we're rotating counterclockwise 360 degrees and then an additional 90 degrees. So I'm going to draw that going that far right there, and this right here is 450 degrees. Negative 900, so in this case right here, let's see, 900 minus 360 minus 360, and I get 180. So the initial side, of course, will be on the positive x-axis, and then we have to rotate clockwise, so we're going to rotate 360, 360, and 180. So going this way, we rotated once, twice, and then 180 degrees for negative 900 degrees. I forgot to print an actual angle there, so don't worry about that one. I can't remember if I crossed these out right here. Maybe not. So find one positive and one negative angle that are coterminal. So to find coterminal angles, that's going to be adding or subtracting multiples of 360. So I guess I could say n times by 360 degrees. So if I want to find something, one positive, so I'm going to add 360 degrees here. So 70 plus 360 is 430 degrees. So this right here is an angle that is coterminal with 70. A coterminal angle is an angle where it would, so for example, 450 degrees is coterminal with 90 degrees. You can see that here that this is 90 degrees, and if I add 360 degrees, so if I go around one more time, I'm going to get 450. Or similarly, if I have 450 degrees, if I subtract 360, I'm going to be the terminal side of the angle. So we have the initial side. The terminal side is going to be in the same position for 450 and 90. So there are infinitely many coterminal angles with any given angle. And in order to find something that's coterminal with any angle, you just have to multiply or you have to add or subtract in 360 degrees or multiple of 360. So in this case, we found one positive, and then we're going to find a negative one, so we're going to subtract 360, so 70 minus 360, and that's going to be negative 290 degrees. So here are two coterminal angles, one that is negative and one that is positive. All right, for 225, so 225, I'm going to simply add 360 degrees. So I get 585 degrees, and then I'll do 225 minus 360 degrees, and I get negative 135 degrees. For negative 125, I'm going to add 360 degrees, and I'm going to get 235 degrees. Then I'll do negative 125 minus 360 degrees, and I'll get negative 485 degrees. Now for 800, this is negative 8. For 8, this is negative 800. So I can actually add 360. So I'll do negative 800, and I'll add 360 degrees to that, and I'll get negative 440 degrees. Now, I'm actually, that's a negative coterminal, but because 800 is greater than 360, I actually just have to add to get a negative. And then I'm going to have to add again. So if I do plus 360 to negative 440, that gives me negative 80. But this right here, these are two negative coterminal angles. But I want one that's positive. So I actually have to add 360 again, and I'll get 280 degrees for one positive, and I actually have two negatives. But all right, moving on to converting degree measure to radians. Yeah, we'll do this now. So if to convert to a radian measure kind of doesn't make. Hopefully you were in class for this. We talked about what a radian measure is, and if you didn't, there's a second part to this homework in which I'll talk about it in that. So this is a degree measure. There are pi radians for every 180 degrees. This is called the conversion factor. So we're going to convert radians degrees to radians by multiplying by pi radians over 180 degrees. The degree measure will cancel, so then I'm going to get 40 pi radians over 180, and then I'm going to simplify. So I can simplify that so that it becomes 4 pi radians over 18, and then both of those are divisible by 2, so 2 pi over 9 radians. So that's what 40 degrees is. 40 degrees is equivalent to 2 pi radian. Yeah. All right, 350 degrees. So I'm going to multiply by pi over 180 degrees. So 315 is divisible by 5. That's going to become 63 pi over 180. That's divisible by 5 over 36 radians. I don't know. Yeah, those are actually both divisible by 3. So 63 divided by 3. That's actually going to be 21 pi over 36 divided by 3. That's going to be 12. Oh my gosh. They're both divisible by 6. Let me go back and simplify that actually. So 63 is divisible by 6. Oh, no, it's not. 63 is divisible by... never mind. 63 is divisible by 3. That gives me 21. And then 36 is divisible by 3. That gives me 12. They're both divisible by 9. That's what they're both divisible by. So 63 divisible by 9 gives me 7 pi. And then 36 divided by 9 is 4. So 7 pi over 4. All right, negative 260 degrees. Let's see. So we're going to multiply by pi over 180 radians. The degrees will cancel, so then I'll get negative 26 pi over 18. That's going to be equal to negative 13 over 9 pi radians. For 500 times by pi over 180 degrees. So that's going to be negative 50 pi over 18. And that's going to be equal to 25 pi over negative 25 pi over 9. All right, now in this case right here, since these are in radians, so this is a radian measure, that's a radian measure, I'm going to multiply by the reciprocal of the conversion factor. So in this case, I'm going to multiply by 180 degrees over pi radians, and then the pi radians will cancel. So then I'm going to be left in degrees. So 180 degrees divided by 9. So 180 is that divisible by 9. That's going to be equal to 20 degrees. So pi 9th radians is 20 degrees. And I'll do similar, multiplied by 180 degrees over pi radians. So radians have to be in the denominator in order to cancel that out right there. And then we'll get, let's see, we'll get 3 times by 180 degrees divided by 4. 180 is divisible by 4, right? So that's going to be equal to 3 times by 45 degrees. And that's going to be equal to 135 degrees. All right. And then as for this one right here, so we're going to, the observation deck of a building forms a sector. So here is the sector with the dimensions shown. Find the length of the safety rail. So that would be find this length right here, and then find the area of the deck. So I'm going to go back to the notes, if I have the notes. Let me go back and look for them. 8.2, nope, 8.2 notes. So if you guys are going looking at your notes, there are formulas for these on this last problem right here. So how do you find the length and how do you find the area? Let me go ahead and copy these over to what we're working on so that we can have them handy right here. All right, so I want to find the length of the safety rail. So that's going to be the equivalent to the arc length. So we're going to say that the rail is going to be equal to, now rail is, I'm writing for S, it's going to be equal to the radius times by theta. So the radius is 10. Now theta, in this formula, theta, the angle, has to actually be given in radians and not in degrees. So I actually have to convert that. So if you remember 90 degrees is equivalent to pi halves radian. So pi over 2 radians. So times by pi over 2. So that's going to be equal to 5 pi. Now 5 pi is equal to about 15.71 yards. Okay, and then as for the area is going to be equal to 1/2 of the radius squared. So 10 squared times by the angle, which is pi halves. So that's going to be equal to 100 over 2 times by pi over 2, which is going to be equal to 25 pi, which is going to be equal to 78.54 yards squared. Okay, now as for the second part, there is a second part to this. I believe that these are all scratched out. Yeah. So you're starting with this one right here where you're drawing the angle using radian measure. So when drawing these angles using radians, if you guys can look up a video on how to draw using radian measure, there's kind of in class. Hopefully you were in class. It's very helpful for this if you were present in class for this lesson, because we went over like 30 minutes of what radians are. So it's a long time not a long time, but it takes a little bit to explain. And maybe a little bit longer to understand. But a radian measure is the measure of an angle that it takes to provide the length of the radius along the edge of a circle. So here's the radius. If you measure that same measure along the edge of a circle, that gives you an angle measure that we call 1 radian. And if you know the circumference, you know that the circumference of a circle is 2 pi r. And if you want to measure how many times can the radius go into the circumference, you'll find using this that the radius can fit around the circumference 2 pi times, which is about equivalent to 6.28 times, and that's what we kind of illustrated here, which is why pi over 180 degrees makes sense. This is a conversion factor, because if 2 pi radians fit around a full circle, 1 pi radian will fit around a half a circle. Alright, so moving on, right here, this is how I like to draw my radians, my angles in radians. I kind of first just look at this little piece right here, because I know that pi radians is 180 degrees, and I'm splitting it into 3 parts, so 1, 2, and 3. So if I split everything into 3 parts, or the full circle, each halves into 3 parts, I can fit 6 pi out of 3 in this full rotation, and I want -4, so that's what the -4 is telling me. So again, I have 3 parts right here. So here's 1 pi. I guess I should count in the negative direction. So right here, this is a pi over 6 measure. This would be a 2 pi over, or a -2 pi. This would be a -3 pi over 6. And then all the way right there would be a -4 pi over, oh, don't know why I'm saying 6. I should be saying 3. Let me actually just say this right here. Each of these is a pi thirds measure. Each of these slices right here, I guess you could say. Because this is 180 degrees, so 3 out of 3 would give me a pi, which again, pi radians is how much is in half of a circle. This would be 6 pi over 3, which is equivalent to 2 pi, which is how many radians are in a full circle, full rotation. And then I want -4 pi, so -4 is going to come in right here where I measure here, and this is the angle that I want. So this angle right here is -4 pi thirds. For 23 pi thirds, so again, same concept. I'm going to take a look right there and see pi 12ths, meaning that each half is going to have 12 parts. I'm splitting up the pi radians into 12, okay, and I want 23. So that means that it's not quite 2, so 12 doesn't quite go into 23. Well, if I want to go, how should I say that? 24 pi over 12 would be a full rotation. This right here would be 24 pi over 12. But I don't quite have 24, so I only want to go to 23 and leave 1/12 open. So if this right here is my initial side, my terminal side will rotate pretty much maybe to like right here. So this right here is 23 pi over 12. And this little slice that I left here is 1 pi over 12. So I want 23 out of 24. And then, yeah, so that would be that angle right there. Pi over 18, this one's really, really easy right here. Just got to imagine that because there's no coefficient here, so there's only 1 pi over 18. Just imagine that this full half right here has 18 different parts, and we're only going 1. And that's actually a pretty small angle, so that should only be about maybe like that much right there. And that's how much we rotated. We only rotated a pi 18th. All right, -25 over 12. So this one, very similar to the one here, where we're in 12ths, except we're rotating clockwise this time, and we actually have to go beyond 1 full rotation, since 12 goes into 25 twice, with 1 more left over. And so the initial side will be measured here. We're going to rotate clockwise, so we're going to rotate all the way around, and then we're going to go 1 more additional remainder. And so you can actually see that this should be the same angle. These are actually coterminal angles right here. Just that this one rotated counterclockwise 23 pieces. This one rotated clockwise 25 pieces out of 12. All right, we got a couple more. Pi thirds. So imagine that you have imagine you split this half into 3 parts, 1, 2, and 3, and we only need 1. So that just means that the angle should just be right there. So that's pi thirds. Now we have 14 pi thirds. So that actually means I need 14 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm actually going to draw that same angle but double. So that right there we know is pi thirds. I'm going to put it over here. And let's see, let's count. So you can always count 2. So this is 1, this would be 2, this would be 3, 4, 5, and 6. So I'd have to go around once to get 6, 7, 8, 9, 10, 11, 12, twice to get 12, 13, 14. So I have to rotate once, twice, so I have to rotate once, twice, and then all the way right there to get 14 pi over 3. All right, now we have 6. So again, looking at the denominator with pi, that's 6. So that means 1, 2, 3, 4, 5, 6. Sorry, that's on the axis. And then there would be another 6 below, and I want 11. So I don't quite want to go all the way. So in this case right here, I'm actually going to rotate just shy of 360 degrees. How shy? 1/6 shy. That's how. That's going to be the difference. So not quite. That would be 12. So probably something like this right here. That right there would be 11 pi over 6. All right, let's see, we have pi thirds, we have negative 10 pi thirds. So a lot of these are in thirds measurements. And so this is also negative. So 1, 2, 3, 4, 5, 6. So I've split the top and bottom parts into 3, and we want to go 10 in the clockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to rotate once, and then I have to go all the way back to here. So it's actually going to be the same measure as this angle right here, but I just got there in a different way. So it should be like right here. I'm rotating once clockwise and then all the way back right there. All right, now finding positive and coterminal angles. Now these we did in the previous part, but these are going to be in radians. So the equivalency to doing this in radians is that we're going to add or subtract 360 degrees, but we're going to do so in radians. And 360 degrees in radians is 2 pi. So 2 pi radians is 1 full rotation of a circle. And so that's what I have to add or subtract from. So in this case right here, I'm going to add 2 pi. But I can't add this right here because they don't have a common denominator. So what to do to get a common denominator is if you multiply 2 by the denominator here, by the value of the denominator, then you can say that 2 times 12 is 24. So if I do 24 pi over 12, this is 2 pi right here, just it has a denominator 12. Now I can add these right here. So this will be equal to 47 pi. So 47 pi over 12. So this is a positive, but we also need to find a negative. So I'll take 23 pi over 12 and I'll subtract 24 pi over 12. So essentially I'm subtracting 360 degrees, and that should be just equal to negative pi over 12. So here is a positive coterminal angle, and here's a negative coterminal angle. And you can do the same thing here. You can use 24 pi or negative 24 pi as the numbers there. Now in this case right here, so I'm going to add 6 pi because I'm going to do 2 times by the denominator in order to get the correct numerator. So 6 pi over 3. Now I have a common denominator, so that's going to become a 4 pi over 3. And then I'll do negative 2 pi over 3, and I'll subtract 6 pi over 3. That's going to be negative 8 pi over 3. So on and so forth. This one right here, I don't need a common denominator. I can just add 2 pi, and then I'm going to get 5 pi. And then I'm going to subtract 2 pi, and I'm going to get pi. So go ahead with these ones that are left, do the same things that I've been doing, and should get the rest of your answers. So, all right, and that should do it for 8.2.